still it's there. Start karo. Okay. So students, really sorry. Actually, there was some technical glitch because of which our streaming stopped. So I think we were at this particular question itself. A monoatomic ideal gas undergoes a process in which the ratio P to V at any instant is constant and equal to 1. What is the ratio? What is the molar heat capacity of gas? If I talk about this particular question, was asked in the year 2006 in the IIT JEE advanced paper. At that time, it was JEE paper only, IIT JEE paper. So a very important but a very typical question of a polytropic process. And in this particular question, they have asked about the calculation of molar heat capacity of gas. You know, there is a direct correlation. There is a direct formula which we can use. Molar heat capacity of a gas, CM. And this molar heat capacity of gas is nothing but CVM, that is molar heat capacity of gas at constant volume, plus R up divided by 1 minus X. And what is this X? It is nothing but the coefficient PV to the power X equals K. If I look at this particular question, P by V equals to 1, so PV to the power minus 1 equals to K, so the value of X is minus 1, right? Now, if it's a monoatomic gas, diatomic gas, which one? Monoatomic gas. For monoatomic gas, CVM is nothing but F by 2R, and for monoatomic gas, F is nothing but 3. So CVM is 3 by 2R. 3 by 2R plus R divided by 1 minus of minus 1. So it's 4R divided by 2. 4R by 2 is nothing but 2R. Student, now if you will ask, from where we have derived this relation? Simple, if you use FLOT, that's nothing but first law of thermodynamics. Q, dq is nothing but dn into cm dt. Du is nothing but ncvm delta t, and this is nothing but work. In terms of work, we can write, right? So nr delta t. So through this, using first law of thermodynamics, I have derived this relation, and through this, we have calculated the molar heat capacity of gas, right? So molar heat capacity of gas is 2. Let's move ahead to the next question. Okay. Once again, this question is taken from the concept of FLOT will be applicable, the concept of adiabatic process will be applicable, the concept of work, everything is included, almost all the thermodynamic parameter is included. So a very typical and a very important question was asked in the year 2012 in the IIT paper itself. So it's a JEE advanced question, once again, was asked in the year 2012. If I talk about this question, it's a MCQ. MCQ, more than one correct. It's all the questions are MCQs only, but this particular question is having more than one correct answer. Let's have a look at the question itself. The reversible expansion of an ideal gas undergoes adiabatic as well as isothermal condition is shown in the figure. Which of the following statement are correct? Okay, so basically a gas is subjected to two different processes. One is isothermal expansion and the another one is adiabatic expansion. If it's a isothermal expansion, which all parameter won't change? Temperature, right? So if initial temperature and the final temperature will be same, so T1 will be equal to T2 only. Perfect, only. Now, if it's a adiabatic expansion, what will happen? Will temperature remain same? The answer is no. Then what will happen to this temperature? The temperature will decrease. Adiabatic expansion is always a cooling process. Why it's a cooling process? Let's derive this relation. du equals to dq plus dw. dq for an adiabatic process is 0. Now its expansion process means dw will be negative. So du will be less than 0. And if du is less than 0 means final temperature is less than initial temperature. Temperature will decrease. So remember the keyword. If it's a adiabatic expansion, cooling. If it's a adiabatic compression, heating. So T3 will be lesser than T1. The second key is wrong, whereas the first one is correct. Now, magnitude of isothermal, they are simply saying W isothermal greater than W adiabatic. Can you say it? Yes. What is work? How do we calculate work if graph is given? If graph is given, if PV curve is given, work is nothing but area under the PV curve, right? So area under this isothermal process will be more as compared to area enclosed in this adiabatic process. So obviously W isothermal is going to be more than W adiabatic, right? Next one. Del U isothermal greater than del U adiabatic. Del U isothermal. What will be the value of del U isothermal? Del U is nothing but NCVM delta T. And if delta T is 0, what will be del U? 0. Whereas this is for iso and this is for adia. And for adiabatic process, just now we have calculated del U is less than 0, right? So obviously U isothermal will be greater than del U adia. Done, students? I hope you are crystal clear with this question. Move ahead. Let's move ahead to the next question. Okay, now this particular question, once again a very typical question, have been asked on this particular questions. It has been repeated several times. The year 2005, 9, 15 JEE Advanced Paper 2, and even in JEE Mains now they are using this particular concepts. Very important one. I suggest please go through this question and try to solve it. I am going to give you 30 seconds to think, to have a look at this question. Let me see at the chat box. Am I audible? Am I audible, everyone? Am I audible? Can anyone say, am I audible? Anyone? Perfect. 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 So shall we start this question? Okay. 1 mole of a monoatomic ideal gas expands adiabatically at a temperature T against a constant external process. Let me underline the keyword. Constant external pressure of 1 atm, perfect, from 1 liter to 2 liters. So it's a expansion process, and adiabatic expansion, find out the final temperature. Okay. If any expansion or compression is occurring against a constant external pressure, tell me the process will be reversible or irreversible. Reversible or irreversible. Reversible or irreversible. All of you. It is going to be a irreversible process. Irreversible process. When our external pressure is kept constant, against a constant pressure, if this expansion or compression is occurring, it's always a irreversible process, because del of P will not be equals to 0 at any point of time, right? And if del P is not equals to 0, means driving force is not same as opposing force, means the process is not reversible. So it has to be irreversible. Now if it's an irreversible process, can I apply PV की power gamma equals to K? Can I apply this formula for a adiabatic process? The answer is no. We cannot apply. If I cannot apply this formula, then how I will calculate my final temperature? Yes, we have a universal formula, and that formula is du equals to dq plus dw, right? If it's a adiabatic process, dq equals to 0. So I have du equals to dw, right? And this du is nothing but n Tm delta T, and that's equals to minus P external into delta V. Now everything they have given, just we need to substitute the data. 1 mole of monoatomic ideal gas. So if it's a monoatomic ideal gas, it's 3 by 2R, right? Delta T is X minus T, and that's equals to minus P external. P external is how much? P external is how much? 1 atmosphere? Yes. So minus 1 into 2 minus 1. So it's this 2 will go that side. So it's 3R in X minus T equals to minus 2 minus 2. Perfect. So 3Rx equals to 3RT minus 2. Let's divide it. We'll have T minus 2 by 3R, right? This is the value of X. And what is X? This X is my final temperature. Final temperature of the gas is going to be T minus 2 upon 3R, and the value of RE is 0.082. T minus 2 upon 3R, correct key will be third one. Done? I hope you are crystal clear with this question. The key concept was constant external pressure. And if it's a constant external pressure, means irreversible process. If it's a irreversible process, we cannot apply PV raised to the power gamma equals to K. I hope it's crystal clear to all of you. Everyone? Done? Done? Shall we move ahead? Moving to the next question. 1 mole of an ideal gas at 300 Kelvin in thermal contact with surrounding expands isothermally from 1 liter to 2 liter against a constant pressure of 3 atmosphere. In this process, the change in entropy of surrounding K. Now, from this question onwards, we have moved to SLOT, second law of thermodynamics. So I need to calculate entropy of surrounding. How do we calculate entropy of surrounding? It's nothing but actual heat transferred upon temperature. If the process is reversible, Q reversible by T. If it's irreversible, Q irreversible by T. Am I clear? Let me write it. So delta S surrounding is always equals to Q actual upon temperature, right? Q actual upon temperature. Now I need to calculate what's the actual amount of heat that's transferred to the system. So it's a 1 mole of gas, thermal contacts, isothermal expansion from 1 liter to 2 liter. Perfect. So isothermal expansion means du equals to 0. Okay. Now, can I calculate the work if du equals to 0, and now we have du equals to dq plus dw. Tell me, each one of you present, d equals to dq plus dw, and this one is 0. So d of q, it's a path, right? Path functions. Sorry. Yeah. dq equals to minus of dw. Now, can I apply the formula of work as nRT ln V2 by V1? Can I apply here? Work for isothermal process is nothing but 2.303 nRT log V2 by V1. But can I apply this formula here? Since the process is isothermal, so we should apply. The answer will be no. We cannot apply. Again, it's a irreversible process. For irreversible process, work is always equals to work during a path W1 to 2 is nothing but minus P external into delta V. The P external is minus 3. The P external is minus P external is 3, and del V is how much? 1 liter to 2 liter. So it's 2 minus 1. So it's minus 3. Now, so 3 atmosphere liter. So what is the magnitude of Q? The magnitude of Q which is transferred to the system is how much? 3 atmosphere liter. This is the amount of heat which is transferred to the system. What is the heat lost by the surrounding? Minus 3 atmosphere liter. So what will be the entropy of surrounding? Minus 3 atmosphere liter. I am going to convert in terms of joule. 1.1 I am taking, divided by 300 is the temperature. So it comes out as minus 1.01, something like that. If they have taken the value of 1, yeah, C is going to be the right key. Am I clear? So this particular question, once again, a very typical question, a typical JEE advanced based question, was asked in the year itself, 2016, and most of the students committed mistake here. What was the mistake? First, constant external pressure, and then this one. And if you look at this particular question, while calculating the work, what they have given the options as nRT ln V2 by V1 value also they have given. If we apply isothermal, reversible, W equals to 2.303 in nRT log V2 by V1, the answer will come out as this one, and it will be a wrong one. Am I clear? Okay, so let's move ahead. Yes. Once again, a very typical and standard formula based question related to concept of entropy. I request you, please go through this question and try to solve it ASAP. Everyone, ASAP, please solve it. Two blocks of the same metal having the same mass and temperature T1 and T2 are brought in contact with each other and allowed to attain thermal equilibrium at a constant pressure. The change in entropy for this process. So here again I need to calculate delta S of the process. Let us try to calculate it. I'm having two blocks. Each one is having a mass m. This one is also having a mass m. It is kept at a temperature T1. At a temperature T1. This is at a temperature T2. Let us assume T2 is greater than T1. So one will lose heat, other one will gain it. No problem. Now, and allowed to attain thermal equilibrium at a constant pressure. The change in entropy, and they have given a specific heat as Cp. Perfect. Is the specific heat. So heat lost will be equals to heat gained. One block will lose heat, other one will gain heat. Let after attaining thermal equilibrium, final temperature is final T equals to Tf. Final temperature is Tf. Now, can I use calorimetry? M into Cp into Tf minus T1 equals to M into P. I'm not using the term molar, so that's why I'm writing directly M, mass into specific heat. I'm taking a Cp as a specific heat into, now this one has gained heat, so it is going to lose heat. Tf will be less than, perfect, cancel out. 2Tf equals to T1 plus T2. So this Tf will be equals to T1 plus T divided by 2. This is my final temperature. Now I need to apply entropy formula. This is going to gain heat, right? So final temperature Tf is T1 plus T2 divided by 2. Final temperature is this one. Initial temperature here is T1. What is the change in entropy? Change in entropy, ds is equals to dq by t, or dq reversible by t, and dq reversible is nothing but ncp dt, ncp dt integral. So it will come as ncp on t final upon t initial, right? So for block 1, delta S1 is the change in entropy, and I can write it as M, or directly let me write it as Cp itself, P on Tf T1. And what is delta S2? Again, on Tf is the final temperature upon initial temperature. Initial temperature for block 2 was T2. Change in overall entropy, delta S1 plus delta S2. Cp I will take common, ln Tf on T1 plus ln of F upon T2. Ln A plus ln B, and ln A plus ln B is nothing but ln of AB, right? Cp on Tf square upon T2, right? Is this clear? Now what is Tf? Tf is nothing but T1 plus T2 divided by 2. So we need to put the value, it will T1 plus T2 whole square upon 4 T1 T2. Let's have a look at the option. P ln T1 plus T2 whole square upon 4 T1 T2. So whenever two block is brought in contact, first we need to apply the law of calorimetry. Heat lost equals to heat gained. Through this, calculate the final temperature. Once you have calculated the final temperature, now calculate change in entropy. Consider it as a reversible process. For system, while calculating entropy, we always consider system as a reversible only, right? System is working reversibly only. And if it's working reversibly, ds equals to dq reversible upon t whole. It's a whole function. Now I need to integrate. Delta S of the system will be, and this dq is nothing but ncp dt, that will come dt upon t will come as ln of t. So it will be a function of log, right? Am I clear? Let's go ahead. I hope this concept of entropy questions was thoroughly clear to you all. These 2 questions or 3 questions are quite important. So whenever you are revising, please go through these questions as it will help you the most while doing the questions of entropy. Okay, so shall we move ahead? Next question. Now, this particular question comes from third law where we use the concept of Gibbs free energy. What is Gibbs free energy? The magnitude of maximum reversible work or the non-PV work? What is non-PV work? Non-PV work means non-mechanical work. Non-mechanical work means non-expansion or compression work, like electrical work, like chemical work. All these comes under non-PV work. Okay. Standard reaction gives free energy for a chemical reaction at a absolute temperature is given by del G at standard conditions A minus BT, where A and B are non-zero constants. Which of the following is true about this reaction? Okay, so they have given a hypothetical equation of Gibbs free energy, and through these equations they are trying to compare the exothermic and endothermic nature of a process. Del G they have given us at a standard condition is A minus BT. Have we studied any formula related to Gibbs free energy? Yes, I hope you remember. Equals to H minus Ts, right? So del G equals to del of H minus del of Ts, and this del of Ts is S dt minus Tds if temperature is kept constant. Del of H minus del of Ts, and if temperature is kept constant, del T will become 0. So it's simply del G equals to del H plus T del S, right? G is a state function, and this is calculated like this: G equals to H minus Ts. Compares or it intakes both enthalpy factor as well as entropy factor. Now, can we compare these 2 equations? Del G equals to del H minus T del S, and here it's BT. Now, if we compare these 2 equations, can I say this A is nothing but del H, whereas this B is nothing but del S, right? If we compare these 2 equations, A is nothing but del H and B is nothing but del S. Perfect? Okay. Now, for a process to be endothermic, del H has to be greater than 0. If it's exothermic, del H has to be less than 0. What about del S? Del S does not decide the thermal parameter like or energy parameter. It has nothing to do with it, right? It only talks about the spontaneity and feasibility of a process. So it does not talk about the energy released or absorption of energy, right? So if del H is greater than 0, process is endothermic. If del H is less than 0, it's exothermic. So if A is greater than 0, means process is endothermic. P, it's irrelevant, endothermic, A greater. So D is the right answer. Done, everyone? I hope it's crystal clear, each one of you. Right? Shall we move ahead? Now, so we are done with the questions of thermodynamics, where we have taken the questions related to degree of freedom. We have taken questions related to first law of thermodynamics, calculation of del U, del of PV. Then there was a question related to a polytropic process, then isothermal adiabatic expansion comparison. Then questions related to polytropic process already we have done, questions related to entropy, questions related to calorimetry, and then one question related to Gibbs free energy. So typically I have covered almost all the important questions might come in any upcoming competitive exam. Now, moving to the questions of thermochemistry. Very easy one. Can you do it? A simple question based on Hess law, heat of constant summation, right? Can you try it? Please try. 2CO plus O2 gives 2CO2. The graphite plus O2 gives CO2 gas. LH for both the process is given. Can we calculate the delH for this given reaction? Now one hint I will give you. Whenever you are calculating delH for any reaction using the above mentioned reaction, always look at the reactants and products. This graphite is in reactant side, so I will keep this graphite on the reactant side. CO is there in the product side, so I will keep CO in the product side. So that means I need to reverse this equation. Am I clear? Whenever you are solving a thermochemical questions, always look at the reactants and products on which side they are mentioned. Am I clear? Okay. Can I do it here itself? Let me do. So I'm going to keep the first one as reverse. So now I will have 2 CO2, and here I'm having only CO. So instead of writing 2 CO2, what I'm going to do, I'm going to divide it by 2. So I will write O2 gas decomposes as O gas plus half O2 gas. Then O gas plus half O2 gas. And for this, the enthalpy change will be x by 2. The enthalpy change will be x by 2. Next one. The graphite graph, let me write it as graph only, plus O2 will give me CO2 gas. And for this, enthalpy is minus y. Now I'm going to add it. So 2 CO2 will cancel out each other. O2 half O2 I will get. What is my final equation? C graphite plus half O2 is giving me gas. For this, if I add any chemical reactions, I need to add the enthalpies also. For the first one, the enthalpy was x by 2. For the second one, enthalpy was minus y. The net enthalpy will be x by 2 minus y. It is x minus 2y upon 2 is going to be the right answer. Right? Simple. Hess law question. Shall we move ahead? Everyone, did you get it? Did you get it, everyone? With Raj. Sir, I'm in 10th and my board exams are from 15th February. How can I please productive? Right now, simple focus whatever you have studied. Just try to write any practice paper you can, right? It will help you a lot. It will help you in boosting your concepts also. Okay. So shall we move ahead? Shall we move ahead? Let's move ahead. The heat of solution anhydrous CuSO4 and CuSO4.5H2O are minus 70 kilojoules and 12 kilojoules per mole respectively. The heat of hydration of CuSO4 CuSO4.5H2O will be. Okay. What do we mean by the term heat of solution? Can anyone tell me what is meant by the term heat of solution? Heat of solution. Anyone? When a solid gets converted to aqueous species. So I'm having CuSO4. This CuSO4 solid, CuSO4 solid plus I'm going to give water, dissolve it until it gets converted to CuSO4 aqueous. Now in this process, the heat released or the energy released is nothing but heat of solution, and this is minus 70 kilojoules. Similarly, the heat of solution of CuSO4.5H2O, CuSO4.5H2O solid plus H2O. I'm going to dissolve it thoroughly in water, and again it will get converted to CuSO4 aqueous, and here it is 12 kilojoules per mole. Now the heat of hydration. What is meant by heat of hydration? The amount of energy released or required to convert CuSO4 to this CuSO4.5H2O. Right? We have added this 5 moles of water as an adduct. So while converting this CuSO4 to CuSO4.5H2O, what is the magnitude of energy? This is nothing but your heat of hydration. Right? I am hydrating it. Right? Now it's getting pentahydrated. Adding water, CuSO4.5H2O. And here the heat of hydration is minus X kilos per mole. Right? So this is on the product side. This is again CuSO4 is here. I have reacted it on the reactant side. If I convert it, it will be minus 12, and then this CuSO4 will go as product side, and if I add it CuSO4 aqueous will get cancelled, so I will get my desired equation. Right? Let me do it. 2SO4 aqueous gives SO4.5H2 plus H, right? This H2O anyhow, and for this the energy is minus 12 kilo per mole. Now I'm having equation 1, equation 3. If I add it, will get cancelled, right? So CuSO4 is getting converted to CuSO4.5H2O. If I add 1 or 3, and this is what we want. This is nothing but the enthalpy of hydration. And in this process, the energy released will be, if I am adding two thermochemical equations, I need to add their heats also. So minus 17, minus 70 plus of minus 12, and that's how much? Minus 82. The value of X will be equal to 2. Energy is released, so minus X minus 82. Value of X is 8. Am I clear? Shall we move ahead? Done? Perfect. So many of you could do it. Perfect. Very good. One. Great work, Sahil. Great work, Kunal. GGYY. Great. Name is itself GY. Great. So let's move ahead. Moving to the next question, which is there on the screen. Now, this particular question is again from thermochemistry, but here we are going to use the concept of enthalpy of neutralization. What is enthalpy of neutralization? The amount of energy released for the formation of 1 mole of water when 1 mole of H plus reacts completely with 1 mole of O. And what's the magnitude of that energy released? the magnitude of energy is minus 57.1 kilojoule per mole. Enthalpy of neutralization, once again I am saying, when one equivalent of H plus reacts with one equivalent of OH minus, I will have formation of one equivalent of water. And during this process, whatever is the energy released, that energy we call it as enthalpy of neutralization, right? So when 1 mole of strong acid giving 1 mole of H plus is treated with 1 mole of strong base, means 1 mole of OH minus, I'll have the formation of 1 mole of water, and the energy is minus 57.3 they have given. Let's take it as minus 57.3. Now they have given one more equation. Here's 3COOH plus NaOH, and it is giving us CS3COONA plus H2O, and for this del H value they have given. Now they are asking us to calculate enthalpy of ionization of acetic acid as calculated by the student. Okay. So what they have given? They have given one equivalent of strong acid, one equivalent of strong base. They are reacting. I am getting one mole equivalent of salt and water. And during this process, the energy released is minus 57.3. Now, what they are doing? They are reacting one equivalent of a weaker acid with a one equivalent of strong base, and in this process the energy released is minus 55.3. Where is the remaining energy? Actually it has to be minus 57.3. Means somewhat this CS3COH, which is a weaker acid, is not giving us one equivalent of H plus. In order to extract one equivalent of H plus, I need to supply certain amount of energy, and this amount of energy is nothing but your ionization energy, right? In order to convert completely CS3COH to CS3CO minus and H plus. Shall I write it? Let's write it. H plus plus OH minus H2O, and here it's minus 37 kilojoule per mole, right? Now this CH3COH will dissociate as CH3 minus plus H plus. Obviously for this process I need some delta H addition. Let me write it. NaOH will dissociate as Na plus plus O minus. Obviously for this I don't need any energy. As soon as it is dissolved in water, being a stronger electrolyte, it will dissociate completely, right? Okay, so now I'm having equation 1, equation 2, equation 3. Can I add all these three equations? Let's add it. So I'm having CS3 OH plus NaOH giving us H plus OH minus OH minus, right? Giving us S3 OO Na minus Na plus H2. This is the reaction they have given us the final. This is my final reaction, and for this reaction they have given the energy as minus 55.3 kilojoule per mole, and this reaction is nothing but the summation of all these three reactions. So for this, delta HR will be equals to delta H1 plus delta H2 plus delta of H3. Delta H1, delta HR is minus 55.3. Delta H1 is minus 57.3. Delta H2 is delta H ionization. And delta H3 is 0. This one will go as the right side, and when it goes to the left side, delta H ionization comes out as 2 kilojoule per mole. A very typical questions JEE means, right? 2 kilojoule per mole is the correct answer. I hope you are crystal clear with this particular question itself. Everyone, done? Did you get this question? So students, with this, we have wrapped up our 2 chapters, atomic structure and thermodynamics, right? Where we have taken few questions from atomic structure and 6 to 7, 8 questions from thermodynamics. Now it's time to move to the next chapter, and that is equilibrium. So shall we start? Okay, let's start. The first question. I think this particular question is related to simultaneous equilibrium. Two reactions are occurring simultaneously in a closed container, and I need to calculate the total pressure when both the solids dissociate simultaneously. Can I calculate? Can I do it? Everyone? Let's try. So I'm having one solid A. This solid is dissociating into gas B gas plus gas. Let us assume it is creating a partial pressure P1. So here also I will have P1, right? Perfect. Now next solid is D solid. It is dissociating as gas plus E gas. From here I am getting a partial pressure P2 and P. Both of them are in the same vessel, and from here getting a certain amount of C gas, and from here I am also getting a certain amount of C gas. So at equilibrium I want to be able to isolate these two individual C, right? At that amount of C which will appear to me will be P1 plus P2 and also P1 plus P2, right? Everyone. Now, for this, the expression equilibrium constant is Kp1. For this, the equilibrium constant is Kp2. Can I write the formula for these two Kp, Kp1 and Kp2? The expressions for these two Kp? Yes. Kp1, which is the equilibrium constant, is the partial pressure of B gas into partial pressure of C gas. That is P1 plus 2 into P1. Similarly, Kp2 will be equals to partial pressure of, I think it's there, and C, yeah, perfect. Partial pressure of E gas into partial pressure of C gas, right? So it's again P1 plus P2 into P2. This is Kp2. Kp1 is X, Kp2 is Y. These two values they have given us. Let's add it. X plus Y. P1 plus P2 into P1 plus P2. So it will be P1 plus P2 whole square. What's P1 plus P2? It's under root X plus Y. Now what is the total pressure inside the container? Total pressure, that is the partial pressure of Pb plus Pc plus Pd sorry, PE plus PC. This is the total pressure. And this is nothing but 2 into P1 plus P2. So 2 under root X plus Y. D will be the right key. Done? Everyone? Is it clear, everyone? Is it clear? Done? Shall we move ahead? Okay. Moving to the next question, and if we look at this question also, again related to somewhat KP, P and all these things, can you do it? Everyone, can you try it? Please try it. A very important question, and I think you must try. Please try it. Yes. I have a doubt. Can you do it, everyone? Please attempt this particular question. Let's N gas plus 3H2 gas is giving us twice of ammonia gas. Okay. The equilibrium constant for the above reaction is Kp. If pure ammonia is left to dissociate, the partial pressure of ammonia at equilibrium is given by the expression, and they have taken or they have assumed partial pressure of NH3 is much or way lesser as compared to the partial pressure of, or as compared to the total partial pressure which we are getting at equilibrium. Means the amount of NH3 left at equilibrium is much less as compared to the total moles of or total amount of gas at equilibrium. We have to use this approximation while solving this question. So shall we move ahead? P, I am going to write directly equilibrium condition. P, 3P, 2P, right? PT will at equilibrium will be equals to P, capital P, and this will be equals to plus 3P. I'm ignoring this one because they have told us to ignore it, right? In the question itself. So 4 into partial pressure of the gas is equal. This is our equation number 1. Now I am going to write the expression of Kp. Kp is nothing but partial pressure of ammonia square upon partial pressure of N2 into partial pressure of H2 to the power 3. Done? Everyone? And what is the partial pressure of NH3? Partial pressure of NH3, let's keep it as partial pressure of NH3 itself. Here, upon partial pressure of N2 is small p into 3p to the power 3. And this is Kp. So Kp is nothing but partial pressure of ammonia here upon P into 3P, right? 27P 4, right? PQ and P4, perfect. Partial pressure of ammonia square upon 27 into capital P on 4 power 4, right? Perfect. So this one will go this side. So Kp into 27 into P4 upon 256 equals to partial pressure of ammonia here. Partial pressure of ammonia will be equal to Kp the power 1 by 2 into pair, right, upon 16 into this 27 will go as 3 raised to the power 3 by 2, right? And this is under root Kp to the power 1 by 2. Let's have a look at the options. Kp to the power 1 by 2, P square, 3 raised to the power 3 by 2 upon 16. D is the right key. Done? Everyone? Everyone? Clear? Perfect. Shall we move ahead? Let's move to the next question. Now, again, a typical question of chemical equilibrium. We'll look at this question. The question says, consider the following reversible chemical reactions. A2 gas plus B2 gas gives twice of AB gas, and 6 of AB gas is giving us 3A2 gas plus 3B2 gas. The relation between K1 and K2. Okay. Can we say it directly without solving? Can you say it? This one, if I need to reverse it, so it will go as power minus of, right? And then it's 3 times. So K1 raised to the power. If I reverse it, 1 upon K1 to the power 3, then it will have 6AB, 3B2, 3A2, then 6AB equals to K2 equals to K1 raised to the power minus. Done? 3 times. If I multiply it, it will go as power into reverse. So 1 upon K1 cube, that's equals to K2, right? Any option? So C is the correct key. Done, everyone? Done? So what we will do here, we'll take a break for 10 minutes and then we'll start our next session on the same link, right? So we are going to pause here for the next 10 minutes and then we'll start, or we'll resume our session. Stay connected. Hello everyone, am I audible? Am I audible? Are you back? Hello everyone, am I audible? Am I audible? Can someone say, am I audible? Okay, okay, okay. Thank you. So, shall we start? Perfect. Moving to the next question, which right now we are discussing the questions of chapter chemical equilibrium. Okay. So, if I talk about this particular question, was asked in January attempt, JEE Mains 2024. So recently asked question, a very standard and a typical questions related to Kp, partial pressure and degree of dissociation. Can you do it? All of you? Let's try to do it. I'm having a gas. This gas is dissociating as B gas plus C by 2 gas. Perfect. P is the total pressure, Kp is the equilibrium constant, and alpha is the degree of dissociation. Now we have at t equals to 0, 1, 0, 0, 1 minus alpha, it is alpha and it is alpha by 2. Perfect. This is how we write. It's t equals to T equilibrium. Now total pressure is given. So can I calculate the partial pressure of each gas? Partial pressure of a gas will be equals to mole fraction into total pressure, and mole fraction will be 1 minus alpha plus 1 plus alpha by 2. 1 minus alpha plus alpha by 2. So it's 1 plus alpha by 2 into P. Similarly, partial pressure of B gas, they write it like this. Alpha is the amount upon total moles, and total moles is 1 plus alpha by 2 into P. And what is the partial pressure of C gas? Again, partial pressure of C gas is the mole fraction of C gas, that's alpha by 2 upon total moles 1 plus alpha by 2 into P. Now I know the expressions of partial pressure of each gas. Now I write the expression of Kp. Kp expression will come out as partial pressure of B gas into partial pressure of C gas to the power 1 by 2 upon partial pressure of A gas, right? And now I need to substitute the data. So it's partial pressure of B gas is alpha upon 1 plus alpha by 2 into P into partial pressure of C gas is alpha by 2. I think it's alpha by 2, right? Yeah, alpha by 2 into 1 plus alpha by 2, perfect, into P to the power 1 by 2, and partial pressure of A is 1 minus alpha upon 1 plus alpha by 2 into, right? This is the expression of Kp, equilibrium constant in terms of pressure. Now can I solve it? So this 2 will come as root, and this 1 plus alpha and 1 plus alpha by 2, 1 plus alpha by 2, this one will cancel out. So it will come out as root only, 1 minus alpha, and this alpha to the power 3 by 2, perfect. And then I will have this P and P getting cancelling out, so P to the power 1 by 2, and then it's alpha and alpha square, right, by 2, 1 minus alpha and 1 plus alpha to the power 3 by 2, something like this. uh, Perfect. It's 1 plus alpha by 2 will go as 2 plus alpha, so 2 plus alpha to the power 1 by 2 into alpha to the power 1 and 1 and half, 3 by 2, perfect. alpha to the power 3 by 2 into p to the power 1 by 2, 2 plus alpha to the power into 1 minus alpha. B is the right key. I hope it's crystal clear to each one of you. Right? I hope it's crystal clear to each one of you. Right? Shall we move ahead? Perfect. Now, next question. The number of moles of NH3 that must be added to 2 liter of 0.8 molar AgNO3 in order to reduce the concentration of Ag plus ions to 5 into 10 raised to the power minus 8 molar. Formation constant is given. Now this particular question is taken from formation constant. A very typical question have been asked in JEE advanced paper as well, and this question was taken from JEE mains 27th August 2021. So a typical question of chemical equilibrium, but an important one. Let us try to solve it. I'm having AgNO3 and this AgNO3 is going to react with ammonia, and and we need to calculate the number of moles of ammonia. So AgNO3 concentration they have given us. What is the concentration of AgNO3? It's 0.8 molar. So AgNO3 being a strong electrolyte, I can say it will act as a source of Ag plus, and the concentration of Ag plus will be 0.8 molar. Right? Now, this Ag plus is gonna react with 2 moles of ammonia, and I will have the formation of a complex that is AgNH3 2 plus. Right? Is this clear? Okay. Now let's write the concentration. T equals to 0. I am having 0.8 molar. Right? So let's assume it as X. Perfect. So 0.8 at T equals to 0. Let's assume I have taken X moles of this one. Now, formation constant is very high. That clearly indicates the reactant is getting almost completely consumed in the process, right? So this Ag will act as a limiting reagent and it will get completely consumed in this reaction. So 1 mole of Ag is reacting with 2 moles of ammonia, right? Most it will get completely consumed, and the amount of ammonia left will be X minus 1.6. X I have taken initially, 1 mole is reacting with 2 mole, so 0.8 will react with 1.6 mole. So the amount left will be X minus 1.6, and the mole of complex formed will be 0.8 molar. It's not mole, it's molar. Am I clear? Now, I need to write the expression of Kf. Kf is Ag diamine silver complex, it's there, upon Ag concentration into NH3 concentration to the power 2. Perfect. Kf value they have given. Kf value is how much? 1.1 into 10 to the power 8. 1 into 10 raised to the power 8 equals to this is the amount of Ag plus that is left. Ag plus left, I can write it as Ag plus left. It's almost tending to 0. So it's how much? 5 into 10 raised to the power minus 8. This is the amount of Ag plus which is left. Okay. So I will write it 0.8 upon 5 into 10 raised to the power minus 8. 5 into 10 raised to the power minus 8, and this is X minus 1.6 whole square. right? So this 10 raised power m will go at as it is. It's nothing but 0.8. So x minus 1.6 whole square equals to 0.8 divided by 5, and mod of x minus 1.6 equals to 0.16 square, sorry. So x minus 1.6 is equals to 0.04 x, sorry, 0.4. So x equals to 1.6 and 0.4, it will come out as 2. So the molar concentration of ammonia that we have taken is 2 molar. Concentration of ammonia is 2 molar. Now I need to calculate the moles, right? Moles is nothing but molarity into volume. The moles of ammonia will be 2 into 2, and that's equals to 4. 4 is the correct answer. Am I clear? Everyone? Is this clear? Do let me know. Is this concept clear? Perfect. So let's move ahead. Now, once again, a very typical question correlating Gibbs free energy, spontaneity, and equilibrium. For a process to be spontaneous, del G has to be negative, right? So, a reaction or any process, a thermodynamic process, will be spontaneous in that direction in which its Gibbs free energy is continuously reducing. If we look at point A, slope is negative, decreasing function. If we look at point B, it's almost a constant. The slope will be line parallel to x-axis, tan theta, 0, right? Whereas if I look at point C, it's an increasing function, slope is positive. Means for point C, can I say del Z will be greater than 0? For point A, del Z is less than 0, and point B, del Z is almost equal to 0. And if change in Gibbs free energy is equal to 0, means the process is at equilibrium. So B points corresponds to equilibrium. What does this A correspond? This A points correspond here, since Gibbs free energy is continuously decreasing, means the process is spontaneous, del G is negative, A will be a spontaneous, B will be equilibrium, and C will be non-spontaneous. Reaction is spontaneous at A, non-spontaneous at C, perfect. Reaction is spontaneous at A and B, no at equilibrium. Reaction is at equilibrium at point B, perfect, and non-spontaneous at point C, perfect. It is also correct. Reaction is non-spontaneous. Reaction is spontaneous at A, perfect, and non-spontaneous at C. This one is correct. Reaction is non-spontaneous at A, no, it is spontaneous. Reaction is at equilibrium at point B, perfect, and non-spontaneous at point C. It's also correct. So B and C are correct. How many statements? 2 statements. Am I clear? Done? Everyone? Shall we move ahead? Perfect. Now, so we are done with the questions of equilibrium, that is chemical equilibrium. Now from here onwards, we are going to take one of the few important, typical, and relatively in this particular segment, you will find somewhat a tougher question on ionic equilibrium. So be alert, be attentive, and be very active. Before I am solving, you try to get the answer. Clear, everyone? The first few questions will be easy, but few questions related to solubility concepts will be a good one. Okay, shall we start? Perfect. The pH of 1 into 10 raised to the power minus 8 solution is 8. Which solution And here it is missing, I think it's HCl. So you can take it as HCl. Perfect. The concentration of HCl is 1 into 10 raised to the power minus 8. And they are saying the pH as 8. No. The acid. So pH has to be less than 7. Right? The amount of water coming, amount of H plus coming from water will also be considered. Right? So it comes around somewhere around 6.8, 6.82 for 10 raised to the power minus 8 solution. So this is completely wrong. The conjugate base of H2PO4 minus is HPO4 2 minus. It's not 2, it's HPO4 2 minus. So this one is correct. If it's HPO4 2 minus, conjugate base, simply remove one acidic hydrogen. After the removal of one acidic hydrogen, the anion formed is conjugate base. For H2PO4 minus, the conjugate base will be HPO4 2 minus. Am I clear? Now, Kw increases with increase in temperature. Perfectly right. Ln of Kw equals to del H upon R 1 by T 1 minus 1 by T. So, if temperature increases, Kw value increases. Right? So, C option is also correct. When a solution of weak monoprotic acid is titrated against a strong base, okay, I'm having a weak monoprotic acid, let's assume it as acetic acid, and it is titrated with a strong base. Let's assume it as NaOH, and I'm going to get CH3COO Na plus H2. Now let's read the statement. When a solution of weak monoprotic acid is titrated against a strong base, half neutralization point H equals to half pK. Half neutralization point means A by 2. A by 2, A by 2. Salt upon acid concentration. Salt upon acid concentration is 1. pH equals to pK. Right, students? Buffer, acid buffer. So this is wrong. B and C are the correct key. Yeah, everyone. Hi, sir. I need your help. 11th was a bad habit. Definitely you can ask Tarun. Chandramohan, thank you. Chandan, are you able to get the answers? So how many of you could solve this particular question? How many of you could solve this question? Kunal, you could solve it? Good. Next question. Very easy one. A very easy one. I'm giving you 20 to 30 seconds. Please try to solve this question. A very easy one. One liner. Even class 11th, for class 11th students also, this session is going to be very useful because you can revise your entire physical, almost all the concepts, the typical questions of JEE main we have taken. Done, Chandan? Okay. 6 mole 100 ml of 0.1 molar HCl is mixed with 400 ml of 0.01 molar H2SO4. I need to calculate the pH of mixture. Okay. Let's first of all calculate H plus total, and H plus total will come out as N1V1 plus N2V2 upon 1 plus. Whenever diprotic, triprotic acids are given, don't use the formula M1B1. Always better to use normality concept rather than molarity concept in ionic equilibrium. Never ever get stuck. So 600 into 0.01 plus 400 into 0.02. Molarity is 0.01 and n factor will be 2 upon 1000 V1 plus V2. This is total H plus concentration. How much? 6 plus 8, 14 upon 1000. 14 into 10 raised to the power minus 3. H minus log of H plus ion. A very easy one. Class 9/10 for problem. Right? So 3 minus log of 14, and log 14 is log 7 multiplied by 2, so 0.85 plus that is 1.143 minus 1.14 will come where around as 1.8. The pH of the mixture is going to be 1.86. Done? Everyone? Correct? How many of you did it correctly? Perfect. 500 ml of, sorry, 50 ml of 0.1 molar acetic acid is being titrated against 1 molar NaOH. When 25 ml of NaOH has been added, the pH of the solution, I think just now we have done this question. Just now, right? 25 into 0.1, 50 into 0.1. So half the neutralization point. At half the neutralization point, we get buffer, right? We'll have acid left, we will have salt. Acid and salt, acidic buffer for acid, and now 2.5, that's 2.5 and that's 5. So 2.5 moles of acid will be there and 2.5 moles of salt will be there. Their ratio is going to be 1. pH equals to pKa plus log of salt by base. Salt is to base ratio is 1. 2.5 upon 2.5, right? So pH is going to be equal to pK, right? A very easy one. Now this question is really important, have been asked in JEE mains as well as in IIT paper. So what I am going to do, I am going to give you 30 to 40 seconds. Have a look at the question and let me see how many of you are able to solve it. Now it's a challenge for you. Solve it ASAP. A good question. Relatively better question. It will help you in revising your solubility concept even concepts of salts and all. Better one. Please solve it. Buffer, high solubility, hydrolysis, everything is there. So please try to solve this question. D. Prasad got the answer D. Okay. Good. Apart from Prasad, anyone else? Yes. Yes, Prasad. Let's start. Let's start this question. AgCN. N is stabilizing as Ag plus plus N minus, right? It will solubilize like this. But now this particular salt is dissolved in a buffer solution and having a pH of 3, right? It is dissolved in a buffer solution. It's not dissolved in water. It's dissolved in a buffer solution. That's maintaining, we are maintaining a pH of 3. So this, as soon as this Cn minus is getting formed from here, this Cn minus will react with H plus, right? Present in the solution. So this Cn minus will react with H plus and I will have the formation of HCN. Perfect. Okay. Let's assume the solubility is S. Solubility will be S. Now, S. Here, the concentration of H plus is 10 raised to the power minus 3 because the pH of the buffer solution is 3. Perfect. Right? Okay. Cn minus being formed in a relatively smaller amount. Why the Cn minus is formed in a smaller amount? Because the Ksp value is too low. It's in the order of 10 to the power minus 10. So if I take the under root, it will be in the order of 10 to the power minus 5. Cn minus concentration coming out from this AgCN will be in the order of 10 raised to the power minus 5, which is way less as compared to 10 raised to the power minus 3. So it will almost get consumed. Will be S, and here I will have almost S getting formed. Now for this, can I write the expression of Ka, and this dissociation constant will be written as HCN upon H plus concentration into Cn minus concentration. And from here I can calculate the Cn minus left, right? I can write it as Cn minus left, simultaneous process. Perfect. So Cn minus left, Cn minus left will be equals to into H plus on, sorry, this is not the expression of K, just the reverse, 1 upon K. So K will be written as H plus concentration into Cn minus concentration upon HCN concentration. So Cn minus left will be written as Ka into HCN upon H plus. Perfect. Dissociation constant H plus into Cn minus, which initially I had written it wrong, K equals to H plus into Cn minus upon HCN, and Cn minus left will be K into HCN upon H plus. Now I know the value of each of these data. So Cn minus left will be equals to Ka into HCN. Ka is how much they have given? 6.2 into 10 raised to the power minus 10. 6.2 into 10 raised to the power minus 10 into HCN. HCN amount is formed is almost S upon H plus, that's 10 raised to the power minus 3. So this is the amount of Cn minus which is left. 10 raised to the power minus 7 into S. Perfect. Now Asp equals to Ag plus into Cn minus left. Perfect. And this Ag plus concentration is S and Cn minus concentration is how much? 6.2 into 10 raised to the power minus 7 into S, and this is nothing but KSP, and KSP value they have given as 2.2 into 10 raised to the power 2.2 into 10 raised to the power minus 10. So it will go as 2.2 into 10 raised to the power minus 9, that's equals to S square into 6.2, and it I will write it as 22 into 10 raised to the power minus 10 upon 6.2. So somewhere around 4 or less than somewhat 4, so it's 10 to the power minus 5, and that's equals to S square. So it's somewhere around 3.8 or 3.9. 3.8 means 19 square, so 1.9. S is 1.9 into 10 raised to the power. This is the solubility of salt. I hope you could understand this question. Let me explain you now. I'm having a salt AgCN. This AgCN, let me take this bottle. This is a buffer solution where the concentration of H plus is 10 raised to the power minus 3. Now AgCN is dissolved in it. After some times, the dissociation of AgCN will occur at a slower rate, right? And Ag plus and Cn minus. Now, as this Cn minus is getting formed, it will react with the H plus present in the buffer solution, right? So AgCN dissociating as Ag plus, Cn minus, S and S. Now, but the Cn minus is not remaining as it is. It is reacting with the H plus present in the buffer solution. So I will write Cn minus plus H plus, giving us HCN. I will write the expression of dissociation constant, from where I will calculate the amount of Cn minus left. Once I know the value of Cn minus left, KSP equals to concentration of Ag plus at equilibrium multiplied by concentration of Cn minus left, and with this we calculate the value of S. Clear? Is it done, everyone? I hope you got it. Done? Shall we move ahead? Okay, let's move ahead. Okay, once again a question related to precipitation, solubility and all these things are very important and typical questions of JEE mains. Try to solve it. A solution is 0.1 molar in Cl minus and 0.001 molar in CrO4 2 minus. Solid AgNO3 is gradually added to it. Let me draw the diagram. I'm having a beaker in this. Cl minus is present. It is having a concentration of 0.1 molar. I'm having CrO4 2 minus 0.001 molar, right? Perfect. Now AgNO3 is added to it. A solid AgNO3 is gradually added to it. Okay. The KSP value of AgCl and KSP value of Ag2CrO4 they have given. Let me write that also. KSP of AgCl, KSP AgCl. How much they have given? 1.7 into 10 raised to the power minus 10. 1.7 into 10 raised to the power minus 10. And KSP of Ag2CrO4 they have given as 1.9 into 10 raised to the power minus 12. 1.9 into 10 raised to the power minus 12 molar cube. Perfect. Now they are asking which precipitate I will get first. Okay, can you do it? Can you do it? AgNO3 is a source of Ag plus. This Ag plus is gonna react with Cl minus. It is also gonna react with CrO4 2 minus. That precipitate I will get first, where the amount of Ag plus consumed will be less, right? That will be easily precipitated. So I need to calculate, check in each of the case, in which case the amount of Ag plus consumed is relatively less. And how do we calculate? So we'll use the boundary condition Ksp equals to P or Ip, I can say, that is concentration of Ag plus into concentration of Cl minus. So amount of Ag plus required will be 1.7 into 10 raised to the power minus 10, and concentration of Cl minus is how much? 0.1. That is equals to the amount of Ag plus left, which is 1.7 into 10 raised to the power minus 9 molar. 2 way lesser, right? Much less. Second one, let's try to calculate the amount of Ag plus required for the precipitation of, let me write it like this, amount of Ag plus required for the precipitation of precipitation of Ag2CrO4, Sp of Ag2CrO4 equals to ionic product, and that is Ag plus pair into CrO4 2 minus. Ag plus required will be equals to under root of Ksp upon concentration of CrO4 2 minus. And how much is this? 1.9 into 10 raised to the power minus 12 under root. So it will be in the order of 10 raised to the power minus 6. Here it is 10 raised to the power minus 9. Which amount is lesser? 10 raised to the power minus 9. So which one will be, which precipitate I will get first? That precipitate where the amount of Ag plus required is less. Just after a few minutes, only when a few drops of Ag, or when a few particles of this AgNO3 will fall into the solution, as soon as I will have the formation of precipitate. AgNO3 is dropping continuously. This AgNO3 is going to react with Cl minus. For this AgCl precipitation, the amount of Ag plus required is in the order of 10 raised to the power minus 10, which is way less as compared to Ag2CrO4 precipitation. So AgCl precipitation will occur first, and then I will get the formation or precipitation of Ag2CrO4. Right? So let's have a look at the options. AgCl will form precipitate first, as the amount of is the right key. Done? Moving to the next question which we have on the screen. Once again, a question related to solubility. Let's have a look at the question. Questions say two salts A2X and MX have the same value of solubility product, then the ratio of their molar solubility. Having a salt A2X and one more salt is there, and that is MX. And for these two salts, Ksp value is given 4 into 10 raised to the power minus. First of all, let's write it. It will dissociate as 2A plus X minus 2S S. Mx will dissociate as M plus X minus S and S. For this, Ksp will be equals to 4sq 2s to the power 2 into S, and for this Ksp will be equals to S into S square, right? In both the case, S1, S1, S2, S2, right? Better, because solubility can't be the same. So 4s1 cube, and solubility product they have given how much? 4 into 10 raised to the power minus 12 for both the salts. So 4 into 10 raised to the power minus 12 equals to 4 into S1 cube. S1 equals to 10 raised to the power minus 4 for first one. Second one, 4 into 10 raised to the power minus 12 equals to S2 here. So S2 equals to how much? 2 into 10 raised to the power minus 6. Now I need to calculate S1 upon S2. 10 raised to the power minus 4 upon 2 into 10 raised to the power minus 6. 100 by 2, that's equals to 50. So the ratio of the molar solubility is going to be 50. Right? Am I clear, everyone? Am I clear? Is this concept crystal clear? Shall we move ahead? Next one, a very important question, typical questions of ionic equilibrium involving the concept of solubility, buffer, right? So, standard one. I think you must pay attention over this question also. The molar solubility of CdOH whole twice is 1.84 into 10 raised to the power minus 5 molar in water. In water, they have given us the solubility of a sparingly soluble salt, and that's CdOH whole twice. And that's how much? 1.84 in 10 raised to the power minus 5. Now they are saying us to calculate the solubility of the same salt or the same base in a buffer. Okay, so how do we do it? They have given us the solubility of BOH, and this is 1 into 10 raised to the power minus 5. This CdOH whole twice will plus twice of OH minus S plus SP. How much? S here, right? So this Ksp is nothing but 4S. Done? Perfect? Okay. Now, so S value we know, so the value of Ksp of this OH whole twice, how much? 4 into 1.84 into 10 raised to the power minus 5 cube. Perfect. Now they are asking to calculate the molar solubility in a buffer, and the buffer is having a pH 12. So pH equals to 12. What will be the value of pH? 2. Right? If pH equals to 12, UH will be 2 minus concentration in the buffer will be 10 raised to the power minus 2. Now this CdOH whole twice will dissociate as Cd2 plus twice of OH minus S, and here I will have 10 raised to the power minus. I will write Ksp of CdOH whole twice as S into H minus concentration की power 2. And this is S into 10 raised to the power minus here. That's equals to how much? What was the solubility product? 4 into 1.84 into 10 raised to the power minus 5, right? So it's 10 raised to the power minus 4. And this is how much? 1.8 into 1.8, that's 3.24 into 1.8. How much? Think you can solve the answer, do this calculation, get the answer, right? Next question. Once again, a typical question of ionic equilibrium related to solubility only. So all these questions are somewhere around from solubility. Will help you in revising the concepts of solubility. Because what we do, initially we study well the concepts of acid, base, pK, the mixture of acids, then the titration, and in the end, when we start solubility, try to mug up, right? Solubility KSP is nothing but S into S or something like this, ionic product. But here, that's why I have taken a bit more question from solubility, so you can understand questions and concepts and how the PYQs are asked. There, everyone? Okay. So the KSP for the following dissociation they have given. I'm having a salt PbCl2. This PbCl2 is dissociating as Pb2 plus twice of Cl minus. It is aqueous, right? Okay. Now, which of the following choice is the correct for a mixture of 300 ml of 0.134 molar lead nitrate and 100 ml of 0.4 molar NaCl? Okay. So, let me take a beaker. In this beaker, I am adding lead nitrate. I am adding NaCl. This NaCl is having a concentration of 100 ml volume and 0.4 molar, 0.4 molar, perfect. So source of Cl minus 0.4 molar, and here it is 300 ml and 0.134 molar, perfect. What will be the concentration of Pb2? And I say it is 300 into 0.134 divided by 300 plus 100, that's 400. This is the concentration of Pb2 plus. Can I calculate the concentration of Cl minus? Cl minus concentration, how much? 0.4 into 100 divided by 400. 300 plus 100, right? So it's 0.1 molar. Now, PbCl2, P, ionic product, or I can say, let me write it as IP itself. IP, ionic product. P2 plus concentration into Cl minus concentration to the power 2. Pb2 plus concentration 3 by 4 into 0.134 into 0.1 here. This is IP, and this IP will obviously be greater than KSP. So QP is greater than KSP. Ionic product is greater than solubility product. Done, everyone? Done? Okay. Oh, okay. So now we are done with the questions of equilibrium. Now it's time to move to the next chapter, and this particular chapter is redox titration. We'll do a few questions of redox, mainly the balancing and few titration questions so that you can revise it at the end time and it will help you a lot. The first question is all about balancing the reaction in acidic medium. Very easy one, but sometimes it's being asked. They have asked in JEE Advanced also related to this balancing of redox, and frequently they are asking this question in JEE Mains. So I have taken this question. Magnate treated with oxalate ion, acidic medium Mn+2, CO2 and H2O. Let me write it. And I will give you a shortcut for this. MnO4 minus plus C2O4 2 minus gives us Mn+2 plus O2. Right? What's the oxidation state of manganese here? +7 plus 2. Change 5. N factor is 5. Oxidation state of carbon here 3. Oxidation state of carbon here 4. Change 1. Atom 2. N factor 2. Now do the crisscross. Write 5 here. Write 2 here. Do the balancing of atoms. Charge balance is done. 2 and now 5 into 2, 10. 10 CO2. Perfect. How many oxygens now? 20. Add 20 moles of water. Oxygen balancing done. Now hydrogen balancing, right? Perfect. Go to here. Just 1 minute. 10, 20. How many oxygens already there? 8 and 20. 20 and 28. And this side 20 only. I need to add 8 of water over here. Right? Okay. Now, oxygen balancing, manganese, carbon, every balancing is done. Only one balancing is there. That's hydrogen. 8 into 2, 16. So, D is how much? 5. How much? 16. X is how much? 2. Y is how much? 10. 5 into 10. Perfect. And water, Z is how much? 8. This one is the correct key. Done? Everyone, is it done? Shall we move ahead? Perfect. Now, once again, an important question related to disproportionation reaction. Balancing of disproportionation in alkaline medium. Can we do it? Very simple. Once again, acid undergoing reduction, acid undergoing oxidation. Yes, 0 and perfect. So this acid is undergoing oxidation as well as reduction. So it's a disproportionation redox reaction. And this balancing we have to do in alkaline medium. Okay. What I will do? I will write acid plus S. One undergoing oxidation, one undergoing reduction. And then I will write here S2 minus. And here I will write S2O3, 2 minus. Rest everything will get automatically added. Let's start. 0, 2, change of 2, atom 8, N factor 6. Perfect. 0, 6, 4, 2. 2x minus 6 equals to minus of 2. So 6, 4, x equals to 2. Again, change is 2 per atom, total atom 8, 16. So 16 is to 16 N factor. It's will cancel out 1 is to 1. So I will 1 add. Perfect. Acid. What I will write now? 8. Perfect. And here I will add O. Done. Balancing of sulfur also done. Charge balancing done. Now, how many oxygen? 12 oxygen. This side. No oxygen this side. So I will add 12 H2O. If it's 12 H2O, how many H plus? 24 H plus. Right? So balancing in acidic medium done. Now, but I have to do the balancing in alkaline medium. So how we can do the balancing in alkaline medium? Add equal number of OH minus plus 24 OH minus 24 H minus. Net reaction acid plus 12 H2O plus 24 OH minus is giving me 8 of S2 minus plus 4 of S2O3 2 minus plus 24 H2O. This side 12 H2, remove it, keep it as 12 H2O. Now one more thing, 2 common, strike it, stay right. Acid 2 I'll take common, final one I am writing, acid plus 12 OH minus will give me 8 of S2 minus plus 4 of S2O3 2 minus, sorry, 8 divided by 2, it's 4 only, 4 of S2 minus plus of S2O3 2 minus plus 6 of O. The value of A they are asking, A is 12. Done everyone? Is this clear? Everyone? Is this concept crystal clear? So how we do the balancing in acidic medium? How do we balancing in basic medium? How do we do the balancing of our disproportionation? Add equal. For one do the oxidation, for the another one do the reduction. And then crisscross the n factor. Once it's done, balancing of oxygen is done by adding water. Balancing of water, H, is done by adding H plus. Balancing is done in acidic medium. Add equal number of OH minus on both sides. Simple alkaline medium balancing done. A very easy question. An example of disproportionation reaction is. What do we mean by the term disproportionation? Undergoing oxidation as well as reduction. +7, +6, +4. So it's going reduction only, no disproportionation. +7, +2, reduction. +1, +2, 0. Oxidation, reduction, disproportionate. The right key. Anyhow, it's not. 0 and -1, so redox reaction. C will be the right key. Now, so we are done with the balancing. We are done with disproportionation, balancing in acidic medium, alkaline medium. So it's time to do somewhat 1 or 2 questions on titration part. So the first question itself is related to hypo, iodometry, iodimetry. Let us try to solve this question. The question says 20 ml of 0.02 molar hypo solution is used for the titration of 10 ml of copper sulfate solution in the presence of excess of Ki using starch as an indicator. The molarity of Cu2 plus is found to be. They have given us 2 redox process, right? And through this, we need to calculate the molarity of Cu2 plus. Okay. I2 getting converted to I minus, and same here I2 is there. I can write one thing, milliequivalent of I2 equals to milliequivalent of hypo, that is S2O32 minus, also equals to milliequivalent of plus. But there is one condition. I can write it. It's a simultaneous equation, right? But this particular formula I can use only when the n factor of I2 in this reaction and n factor of I2 in this particular reaction is same. If it's not the same, we cannot use this law of chemical equivalence. Then we need to balance the reaction. We need to solve these equations using law of stoichiometry, mole concept. But since the mole n factor is same, 0 changes 1, 2, n factor changes n factor 2. If n factor of the common species is same, I can use milliequivalents of A equals to milliequivalents of C equals to milliequivalents of E. The common species must be the same. Am I clear? Okay. So now milliequivalents of hypo. How can I calculate milliequivalent of hypo? Molarity they have given. So normality of Na2S2O3, how much? Na2S2. What will be the normality? 6 to 4 plus 2 oxidation state, and here it is plus 2.5 oxidation state. Change is 0.5 atom 2, so 1. So its normality is 0.02 into 1 itself, that's 0.02. Volume is how much? Volume is 20 ml. I can calculate the milliequivalents of MEQ of hypo Na2S2O3. One will be 0.020. And since milliequivalents of hypo will be finally equals to milliequivalents of copper, so I can write is equals to MEQ of 0.02 into 20 equals to milliequivalent of copper. Volume of copper they have given n factor plus 2, 2 plus 1, 1. N factor is 1 only. So 10 into normality, let me write first of 2. So n is 0. Since n factor is 1, so molarity will be same as normality, which is equals to the concentration of CO2 plus, and that will be 0.4. Done? Perfect. Let's move ahead. Next question. 0.01 molar KMnO4 solution is titrated with 20 ml of 0.05 molar more salt solution through a burette. Perfect. The initial reading of 50 ml burette is 0. The volume of KMnO4 solution left in the burette after endpoint. Simple titration question. Titration of KMnO4 in acidic medium. In acidic medium, the n factor of KMnO4 comes out as 5. So normality will be 5 times molarity. So normality of KMnO4 will be equals to 0.01 into 5, right? And volume of KMnO4 they have not given. So or in the titration we have to in this particular questions we need to calculate the volume of KMnO4 consumed during the titration process. The initial volume is given. If we calculate the volume consumed, definitely we can calculate the final volume left in the burette or the reading of the burette, right? Okay. So simple titration, N1 V1 equals to N2 V2. N1 is how much? 0.05 into volume consumed is V, let us assume, and 20 into 0.05 more salt, N factor will be 1 only. What is more salt? FeSO4 dot NH42SO4 6H2O, right? So anyhow the N factor is going to be 1 only. So molarity will be same as normality, right? Okay. So from here the volume comes out as 20 L. This is the volume consumed during this titration process. What was the initial volume? Vi was 50. What will be F? 50 minus 20. 30 ml is the amount of or the volume of KMnO4 remaining in the solution, right? Next question. Once again, a question related to titration only. Titration of K2Cr2O7 in acidic medium. And this K2Cr2O7 is titrated with Fe plus 2. Okay. K2Cr2O7, potassium dichromate. What is the N factor? N factor is 6. Right? So what will be the normality? Normality will be N1 0.02 into 6 plus 6 to plus 3 oxidation state in acidic medium, right? Okay. What is V1? 20 ml. Obviously, this K2Cr2O7 will oxidize this Fe plus 2 to Fe plus 3. So change in oxidation state will be 1. So N factor will remain as it is. So I don't need to bother about the N factor. Molarity and normality will be same. N1 V1 equals to N2 V2 0.1.2 sorry 0.12 into 20 10 into N2, right? N2 is how much? 0. The normality or the molarity of Fe plus 2 required will be 2.4 molar 24 into 10 raised to the power minus 2. Am I clear, everyone? Is it done? Perfect. So with this, we are done with the physical chemistry part of class 11th. Now we'll take a break for a few minutes, 15 minutes, and then again we'll come back. Stay tuned. Hello everyone. Am I audible? Am I audible? Please let me know. Namaste, namaste everyone. Am I audible? Am I audible? Good evening, good evening. Am I audible? Please do let me know. Okay, okay, thank you. So let's start our session. And now we are going to discuss about class 12 physical chemistry. We are done with the syllabus of class 11 PC. In this particular session, we have taken questions from atomic structure, thermodynamics, thermochemistry, ionic equilibrium, chemical equilibrium, and redox titration. Now it's time to move to class 12 physical chemistry, and 12th PC will start with the chapter liquid solution. Relatively easy one, but highly scoring both for JEE mains as well as JEE advanced. So let's start our discussion. The first question is taken from the concept of vapor pressure, or I can say Raoult's law, right? Okay. This particular question was asked in the year 2019 April attempt, right? Important question and a typical one, conceptual. So let us try to solve it. I'm having two liquids. One is M and the other one is N, and they form an ideal solution. The vapor pressure of pure liquid M and N are respectively 450 and 700 mmHg respectively at the same temperature. Correct statement is, they have given us the vapor pressure of two liquid. One is M, so vapor pressure of liquid P naught, if the pure vapor pressure is P naught, so P naught M is 450 mmHg, and they have also given us the vapor pressure of pure liquid N, P naught N, and that's 700 mmHg. Which one is more volatile? Obviously N. Volatility of N is greater than the volatility of M. Am I clear? Tell me. I hope this is crystal clear. Volatility of N is more than that of M. Now, chi-m and chi-n they have given. What is chi-m and what is chi-n? It's the mole fraction in the aqueous phase. And one more thing they are saying, ym and yn also. Ym is the mole fraction of liquid M in the vapor phase, and yn is the mole fraction of solvent N in the vapor phase. Perfect. And now I need to find the relation or correlation between these two ratios. Let's try to find out. Let's do one thing. Let's try to calculate this ym. How do we calculate ym? Ym is nothing but partial pressure of M upon total pressure. And partial pressure of M can be written as P naught M, P naught M into chi M divided by Pt. Similarly, I can calculate the mole fraction of liquid N in the vapor phase, and this is Pn upon Pt, partial pressure of N, liquid N upon total pressure. And what is partial pressure? Vapor pressure of pure component into mole fraction of that particular component, right? So it is Pn naught into chi n upon Pt. Let's try to find out the ratio. Ym upon yn equals to this Pt will get cancelled, so it's Pm naught into chi m upon Pn naught into chi n, and Pm naught is how much? 450 upon 700. So this Ym upon yn is 450 upon 700 into Km upon Kn, right? So Ym, and it's less than 1, right? So this Ym upon Yn ratio is point something less than 1 into Km upon Kn. Can I say this? Now we need to find the correlation. Km upon Kn, which one is greater? So okay, just at what we have calculated. So this. So Ym upon Yn divided by Km upon Kn is how much? Is less than 1. It's 450 upon 700. So Ym upon Yn is less than Km upon Kn. And do we have any option? Ym upon Yn is less than Km upon Kn is the correct key, right? Shall we move to the next question? Okay. So what I will do, I will write the question. I will display the question. Please solve it. I will just come in a minute. So if we have a look at this particular question, the question says at room temperature, a dilute solution of urea is prepared by dissolving 0.6 gram of urea in 360 grams of water. If the vapor pressure of pure water at this temperature is 35 mmHg, lowering of vapor pressure will be, lowering in vapor pressure is delta P upon P naught, right? And this delta P upon P naught will be equals to mole fraction of, mole fraction of solvent. Delta P upon P naught, this question is related to RLVP. Mole fraction, and it's a dilute solution, so obviously I can write mole fraction of urea as N upon N. Moles of urea upon moles of water, because N plus a small n will, this small n value is very less, way less, right? So it's 0.6 upon 60, and this is 360 grams, so it's 20. So delta P upon P naught is how much? 1 by 2000, right? 10 times 6 and 100, 2000. So delta P is how much? P naught upon 2000. 35 upon 2000, somewhere related to 0.00017 mm of Hg. Am I clear? Shall we move ahead? Done? Okay. Moving to the next question. For 1 molar aqueous solution of the following compounds, which one has the highest freezing point? Freezing point del F is nothing but T naught minus Ts, right? So lesser the value of Ts, higher is the value of delta Tf, depression in freezing point, right? Now I need to calculate, so highest freezing point, which of the following will show the highest freezing point? Means for which of the following solution Ts is max, means del Tf is least. Now we have studied this formula, delta of Tf is equals to I times Kf times m. Now it's constant. So delta Tf is directly proportional to I Van't Hoff factor. More is the value of I, more will be the delta Tf. And if more is delta Tf, lesser is the Ts. But I need to find maximum Ts. So for this, I has to be less minimum. Now in which case the Van't Hoff factor will be less? In that case, Van't Hoff factor will be less where the number of ions in the ionization sphere is less. If I look at this particular option, no anions are present in the ionization sphere. I is one only, right? So this particular solution will have highest freezing point. A solution contains 62 grams of ethylene glycol in 250 grams of water is cooled up to minus 10 degrees centigrade. If Kf is 1.86 Kelvin kilogram per mole, then the amount of water separated as ice will be a very typical question, but one of the most important question of colligative property, or one of the most tougher questions of colligative property. So what I will suggest, please pay attention while I solve this question. I'm going to take a beaker. In this beaker, obviously water is there as a solvent. Now I am going to add ethylene glycol in it, and I am adding 62 grams of ethylene glycol. The amount of water is 250 grams. Perfect. What is the molecular weight of ethylene glycol? It's H2OH. H2OH 17, and this one 14, 31, 31 into 2, 62. 62 is the molecular weight. Perfect. What is the moles of ethylene glycol? Moles of solute is how much? 1. Perfect. Okay. Now what is final temperature? Final temperature is minus 10 degrees centigrade. So what is change in the temperature? Delta T. This is exact of 10 Kelvin or 10 degrees centigrade. The difference is same, right? Am I clear? So delta is nothing but 10. Now, what's there in this question? What's the beauty of this particular question? Ethylene glycol is added. As I keep adding ethylene glycol, the freezing point of solution will go lowering, right? Delta T value, because delta T is directly proportional to polarity. As I keep adding the amount of solute, so this one will I will have more and more value of delta T, and if delta T value is increasing, Ts value will continuously decrease, right? Up to a point, if I am taking this, is minus 10 degrees centigrade the freezing point of this particular solution? The answer is big no. But still I have dropped the temperature to minus 10 degrees centigrade. And let us assume at minus 10 degrees centigrade, some X amount of water is present in the solvent form. So where all this water has gone? The freezing has started at somewhere around 6 or 7 degrees centigrade itself. But I have reduced temperature continuously, and now I am maintaining a temperature of minus 10 degrees centigrade. So obviously some amount of water will get converted to ice, right? Let us assume the amount of water left is X. Amount of water left is X gram. Can I calculate the molality? Molality will be 1 moles of solute upon X into 1000. Right? Now, I have the formula delta T equals to I times Kf times M. I is 1 because it's a non-electrolyte, right? So delta T, I can write I as 1 because I don't know the proper behavior of this CH2OH in the solution. So I will take it as 1 only into 1.86 1.86 into 1 into 1000 divided by x, right? Am I clear, everyone? Is this clear? So delta TF is I into KF into M, and M is this much. So can I calculate the value of x from here? The value of x comes out as 1.86 into 1000 divided by 10, and it's 10, so 186 gram. 186 gram of water is remaining in the solvent form, whereas initially in the beaker I have taken 250 grams of water, right? Initial amount of water taken is 250, whereas 186 is the final amount of water remaining. Final mass of water is 186. So what amount of water got converted to ice? It's 64. This is the right answer, right? So a very important question. Next one, a question related to osmotic pressure. Can we solve this particular question? Yes. I'm having a acid HX and it's dissociating as H plus and X minus. Perfect. HX is dissociating as H plus plus X minus. Let us keep it as the concentration is given. Okay. C minus X, X and X, right? X amount has dissociated, so X amount will get formed at X amount. And they have given us the value of Ka also. So Ka is nothing but X square upon C minus X. X I am taking very less as compared to C. So this X is under root Ka upon C. I have done the approximation here. 1.2 into 10 raised to the power minus 5 upon C is how much? 0.03. So it's 12 into 10 to the power minus 6, and 10 to the power minus will go as 10 to the power minus 4. So it's 2 into 10 raised to the power minus 2. This is the amount value of x, right? X is this much. Am I clear? Now, although we can solve quadratic if you wish, and then osmotic pressure is nothing but C plus X minus X plus X plus X, that is C plus X into R into T. We have the value of X from here, and then we know C is 0.03, 0.03 plus something X into R value is already given, and the temperature is 300 Kelvin, so we can calculate it, right? Next question. Moving to the next question. Now, this question is a very, very typical question and an important one. A very important question. When it was asked, most of the student has committed mistake. I will tell you what was the mistake. So that's why I have taken this particular question. What does this question say? I'm having an artificial cell is made by encapsulating 0.2 molar glucose solution within a semi-permeable membrane. The osmotic pressure developed when the artificial cell is placed within 0.05 molar solution of NaCl at 300 Kelvin. Perfect. So I'm going to take a beaker. In this beaker, I'm going to take NaCl. Right? I have taken NaCl, and the concentration of NaCl is 0.05 molar. Right? Now, in this solution, I am placing a capsule of glucose, and this glucose is having a concentration of 0.2 molar, sorry, is having a concentration of 0.2 molar. Please pay attention. Okay, right? This is the final scenario. Now I need to calculate the osmotic pressure. First of all, tell me, will osmosis occur here? Let us assume this one as our semi-permeable membrane. Let's take this one as our SPM. So will osmosis occur here? And if yes, from glucose to sodium chloride or from sodium chloride to glucose solution, where this movement or flow of solvent will occur. Glucose I value is 1, for sodium chloride I value is 2. So if I take I1C1 of sodium chloride, it's 0.05 into 2, so it's 0.1, whereas glucose it's 0.2. So dilute solution is NaCl. So the movement of solvent will occur from NaCl to glucose through this semi-permeable membrane. This sodium chloride solution, the movement of water will occur from sodium chloride solution to glucose solution, right? And now as this movement will occur, some hydrostatic pressure will be developed. In order to stop the movement, I need to apply pressure, and that pressure will be your osmotic pressure. And till when this movement will occur? Until the concentration gradient is same, right? So if I add that much amount of pressure, obviously the movement will stop. So what's the concentration gradient here? The concentration gradient del C is I1C1 minus I2C2, 0.2 minus 0.1 into 1, and it's for 0.05 into 2, so that's why I have taken 0.1. So it's 0.1. Because of this much concentration gradient, this osmosis is occurring. If I apply pressure, which is if I apply pressure, obviously this of can I say this is our concentration gradient, and because of this particular concentration gradient, the solvent movement is occurring. If I apply this much amount of pressure, obviously the movement will stop, and this will be our osmotic pressure. So this is nothing but 0.1 into R, I1C1 minus I2C2 into R. R is 0.083, 0.083 into temperature, and the temperature is how much? 300. So this is our final osmotic pressure. Clear? Shall we move ahead? Moving to the next question. Colligative property, we have done RLBP, we have done questions related to Raoult's law, we have done questions related to depression in freezing point, we have done questions related to osmosis. Now, one more colligative properties question was left, or one particular topic was left, that is elevation in boiling point, and this particular question is asked from that topic only. So I'm having a salt or electrolyte AB2 which ionizes as A2 plus twice of B minus. Consider it as a strong electrolyte or degree of ionization, so it's not a strong electrolyte. 1 minus alpha, alpha, 2 alpha. So NT is equals to 1 plus twice of alpha. This is my Van 't Hoff factor even. Final moles upon initial moles. So it's 1 plus twice of alpha, right? Now, 10 gram of an electrolyte in 100 gram boils at JEE. So what is delta TB? Delta TB, elevation in boiling point, is the boiling point of solution, boiling point of solution minus boiling point of pure solvent, that's 100.52 minus 100, that's 0.52, and this 0.52 will be equals to I, that is 1 plus 2 alpha, 1 plus 2 alpha into Kb, and the Kb value is how much? 0.52 into molality, and molality is 10 upon molecular mass is given, and mass of perfect 10 upon 200, 200. This is mass of water into 1000. From here, I can calculate the value of alpha. Right? Done, everyone? Let's move ahead. Now, so we are done with the questions of electrochemistry, sorry, liquid solution. It's time to move ahead to the next chapter. And the next chapter which we are going to discuss is electrochemistry. A very important chapter, a relatively a tougher chapter, but highly scoring one. Right? So, shall we start? Perfect. I'm having a electrochemical cell. Which of the following is correct? If we look at this question, it was it is asked from the concept of galvanic cell or electrochemical cell, right? Daniel cell, voltaic cell, whatever you say. And mainly cell combination. So we need to calculate E naught, and then we need to check the spontaneity. If E naught is positive, del G equals to minus NF E naught, del G will be negative, cell reaction will be positive, right? So how do we check? Let's see. The reduction potential of M plus 2 they have given. Perfect. And it's 0.46. The reduction potential of X is also given. It's 0.34. Which one is having higher reduction potential? SRP of which cell is, or which metal or ions is higher? That is for M plus 2. So SRP of is higher for this one. So can I say it will act as a cathode? It will get reduced. Then this one will have to act as a anode. Now this X2 minus will get oxidized to X, and for this E naught will be minus of 0.34, and for this one obviously it is acting as a cathode. SRP value is given. So E naught cell, if I make a cell like this one as anode, so X2 minus 2X, and then M plus 2 to M. If I make a cell like this one will have a E naught value 0.46 minus 0.34, so 0.12. So M plus 2 is getting reduced, and this is nothing but X2 minus, and X2 minus is getting oxidized. It's a spontaneous reaction, and the cell, if I write it in the IUPAC convention, if I write this galvanic cell, it will be like this. X2 minus aqueous will get oxidized to X. I don't know whether this X is gaseous species or anything. Let's write it like this. Salt bridge. Now I will have M plus 2 getting reduced to M solid. Right? Perfect. So let's move ahead. Moving to the next question. Once again, a very important and a typical questions of JEE mains. Highly important. Whenever you want to revise your electrochemistry, please do revise this particular question. Typically, and several times it has been asked in different shifts of JEE mains in different year, 2023, 22 also it was asked on the similar concepts. So one of the questions I have taken, the question says, the reduction potential of FeO4 2 minus to Fe plus 3 is 2.2 volt. Fe plus 3 to Fe plus 2 is 0.7 volt. Then I need to calculate the reduction potential of FeO4 2 minus to Fe plus 2. For this one is useless. We don't need it. Now, FeO4 2 minus, iron is in 8 plus 6, right? Plus 6 oxidation state plus 3 electrons is giving me Fe plus 3, and for this delta Z1 is how much? Minus 3 into F into 0.2. Delta Z is minus NFE, right? Similarly, Fe plus 3 will accept one more electron. Now it will get reduced to Fe plus 2, and for this delta G process is minus 1 into F into 0.7. Let's add these two equations. FeO4 2 minus plus twice of electron, 4 electron gives Fe plus 2, and for this delta G will be delta G1 plus delta G2. Now one question, why I am calculating this delta G? If I am adding these two equations, their EMF should get added, but no, as we have studied, EMF is an intensive property. It cannot be added directly, but delta G is an extensive property, can be added. So if we calculate delta G, we can easily add. So what we have done, delta G of the reaction is delta G1 plus delta G2. And what is delta G of this particular reaction? Minus 4. What is 4? Number of electron transferred into F into E naught cell, right? So minus 4 Fe minus 4 into F into E naught cell, that is equals to minus 3F into 2.2 plus of minus F into 0.7. F will cancel out. Common I can take. So its E cell is equals to 2.2 into 3 plus 0.7, right? 0.7 only. Okay. Yeah. Upon 4. Right? So this is the correct key. Shall we move ahead? Now, once again, a very typical question, a very important one. Let's have a look at this question. JEE, variation of EMF of a cell with respect to temperature at a given pressure is given. d upon dt upon constant pressure at a constant pressure is given. Now, which of the following cell would be more convenient to use? Right? Can you solve it? Everyone, can you try it? Let's try it. Can we try it? Let's try to solve it. Might have studied one equation, dz equals to vdp minus sdt. Have you studied this? Several times in thermodynamics, right? Now, at a constant pressure, what is this vdp? 0. So dz equals to minus s of dt, and dz is minus nf de, right? That's equals to minus s dot dt d upon dt, right? Into nf at constant pressure is nothing but entropy. So what is basically d upon dt representing? EMF variation, and somewhat it relates to entropy. Higher the value of d upon dt, higher will be the entropy, more will be the randomness, right? So we want that particular cell where the randomness is less. So d upon dt at constant pressure has to be less. That cell will be preferred for the flow of electrons. So which one? Where d upon dt value is less, so that s value will be finally less. in option number C. C will be the correct key. Am I clear? Everyone, is this particular concept clear? Then next one. Once again, a questions related to Nernst equation. A reaction is given. They have given the standard reduction potential for this particular reaction. And now they are asking, at a given condition, at a pH equals to 5, what will be the EMF of the cell? Let's have a look at this reaction. And I see it's nothing but oxidation reaction of water. Oxidation reaction of water. Right? It's nothing but oxidation reaction of water. And they have given the reduction potential. Standard reduction potential. So can I calculate standard oxidation potential? SOP. It's minus 1.23 volt. Right? Clear, everyone? Now, so SOP value is given, cell reaction is given. Can I write Nernst expression? E cell is equals to E naught cell minus RT by NF. That's 0.059 upon N log of Q. What is Q? Reaction quotient. Can I write the expression of Q here? Q is nothing but partial pressure of oxygen into H plus concentration raised to the power 4. Right? This is Q. What E cell value they have already given to us? E naught cell value. Okay. What's N? N is 4. E cell is equals to minus 1.23 minus 0.059 upon 4. Partial pressure of oxygen they have given as 1, so I am not taking it. Log of H plus raised to the power 4. This 4 will come this side, so I am directly cancelling out, right? Okay. So now E cell equals to minus 1.23 plus 0.059, and this minus of log H plus is nothing but pH. So minus 1.23 plus 0.059, and the pH is how much? 5. Right? So 0.06 you can take. So 0.06 into 5 is nothing but 0.3. 0.3 means it's minus 0.93 volt will be the right answer. Clear, everyone? Shall we move to the next question? Again taken from Nernst expression itself, KSP, they have given COH whole twice. They have given take this value. Okay. Shall I give you the hint? Okay. So I need to calculate the standard reduction potential they have given. Just they are asking to calculate this pH. What will be the reduction potential? So E Cu plus 2 reducing to Cu is equals to E naught Cu plus 2 reducing to Cu minus 0.059 by 2 log of Cu plus 2 is getting reduced, right? And now you will say how I am going to calculate the CO2 plus concentration. This Cu KSP they have given. KSP is how much? 1 into 10 raised to the power minus 20. So it's nothing but C2 plus concentration into OH minus concentration sphere. What's the pH? 14. So H plus concentration 10 raised to the power minus 14. OH minus concentration 1 only. Cu2 plus concentration 1 into 10 raised to the power minus 20. This is my Cu plus 2 concentration. Now once I know Cu plus 2 concentration, I can calculate. So it's how much? 0.03, sorry, 0.34. 0.34 minus 0.059, right, upon 2 log of 1 upon this is 10 raised to the power minus 20. It will go as 10 raised to the power 20 10 times, so minus 0.25 will be the final answer, and it's saying minus this, so x is 25 into 10 raised to the power minus 2, minus 0.25, right? So the value of x is 25. Important question, and it was asked in the year 2023 itself. So yeah, still the standard is maintained. We are having a questions like this. We need to be very cautious during the exam when we are solving a question like this. Next, okay. Now this particular question, if I talk about this question is related to metal insoluble salt electron. Okay, so they have taken from one side, they have taken hydrogen electrode, and the other side they have taken as metal insoluble salt electrode. Now what they are asking to calculate the standard reduction potential of this insoluble salt electrode. What they have given? They have given EMF of the cell. At the same time, they have given the concentration of H plus and Cl minus. Okay, so let's first of all write the cell. It's H2, I think, H2 getting converted to HCl, having a concentration of 10 raised to the power minus 6. Salt bridge, now we'll have AgCl, Ag solid, perfect. AgCl, Ag solid, and then with even inert electrode PT, perfect. Let's write the overall cell reaction. I am going to write the detailed particular solution of this particular question so that you understand and you learn how to write the cell reaction. H2 getting converted to H plus. H2 gives twice of H plus at anode, right? Plus 2 of electron, right? This is the cell reaction occurring at anode. Now at cathode, what's happening? Cathode reaction is somewhat typical. First of all, this AgCl will solubilize, and this AgCl will solubilize as Ag plus aqueous plus Cl minus aqueous. Once I am getting this Ag plus will now get reduced to Ag solid. At anode, I am having 2 electrons, so right, perfect. Now let's write the overall cell reaction. H2 gas plus twice of AgCl. H2 gas plus twice of AgCl gives Ag solid plus 2H plus aqueous plus 2 of Cl minus aqueous. Cl minus coming from here will be less. So in the overall cell will take the Cl minus coming from HCl itself, right? Now, what's the number of electron transferred in this process? 2. What is the expression of Q? The expression of Q for this particular reaction will be H plus square upon into Cl minus square. H plus concentration square into Cl minus concentration square. Aqueous form. I am not writing aqueous always. So now, so I know Q, I know this one. Now what is E cell? E cell is equals to, sorry, cell equals to E naught cell minus 0.059 by n log of Q, right? Perfect. Okay. And what is this E naught cell? For anode, the standard oxidation potential for hydrogen electrode is assumed to be 0 plus X, because for cathode we need to calculate minus 0.059 by 2 log of H plus into Cl minus concentration square, and this 2 will come out over here, will cancel out. So it's simply H plus into Cl minus 10 to the power 6 into 10 to the power minus 10 to the power minus 12. So, and how much they are saying? Take it as 0.06. Yeah. In order to ease out our calculation. So 0.92 is the EMF of the cell they have given is X minus 0.06 into 12, right? 10 raised to the power minus 6 into 10 raised to the power minus 6, 10 raised to the power minus 12, and minus, sorry, it's plus. And that's that's equals to 0.92. X equals to 0.92 minus 0.72. So this is 0.2. So the standard reduction potential, I will write it completely, E naught AgCl to Ag to Cl minus aqueous will be retaken as 0.2 volt. This is the correct key. Yeah. Shall we move ahead? Let's move to the next question. Now, if we look at this question, so now we are done with the questions of galvanic cell. Now we have moved to electrolytic cell, but please remember all these questions which we have done from galvanic cell are really important one, the typical questions which are getting frequently asked. So please revise whenever you are going to write your exam. The mass, now moving to the next question. The question says, the mass of zinc produced by electrolysis of zinc sulfate solution with steady current of 0.015 ampere for 15 minutes is. Okay. So I need to calculate the mass of zinc produced, right? And from zinc sulfate. So it's there in the form of Zn plus 2, and this Zn plus 2 is getting reduced, right? And it's getting converted to zinc solid, getting deposited at a respective electrode. So 2 moles of electron is able to deposit 1 mole of zinc solid, right? 2 moles of electron is able to deposit 1 moles of zinc solid. Now let's have a look how many moles of electron we are supplying. So we are supplying current of how much? 0.015 ampere. 0.015 ampere. The time is 15 minutes. 15 minutes. So it's how much? 60 into 15. So time is 900 seconds. So how much charge we are supplying? Q equals to IT. That's 0.015 into 900. This much charge we are supplying. Now how many moles of electron we are supplying? That's charge divided by 96500. This is the moles of electron we are supplying. 0.015 into 900 divided by 96500. This is the total moles of electron we are supplying. Now 2 moles of electron is able to deposit 1 mole of zinc. So this means any moles will deposit how much? Let me write here. 2 mole electron is able to deposit 1 mole of zinc plus 2 plus. So how many moles of electrons we are supplying? 0.015 into 900 divided by 96500. This much will supply 1 by 2 into 0.015 into 900 by 96500. This is the moles of zinc getting deposited. I need to calculate mass. Mass of zinc will be moles of zinc into molecular weight. From here, you can easily calculate. Right, everyone? Shall we move ahead? Shall we move ahead? Let's move ahead. Now, if I look at this particular question is taken from conductivity or conductance. To be very precise, this particular question is taken from Molar's law. At infinite dilution, each one of the electrolyte or ions contribute to the total molar conductivity or equivalent molar equivalent conductance, right? So let's have a look at this question. 1 into 10 raised to the power minus 5 molar AgNO3 is added to a 1 liter of saturated solution of AgBr. Perfect. The conductivity of this solution is, they have given the KSP, okay, lambda naught Ag, lambda naught Br, lambda naught of NO minus. We need to calculate specific conductivity of each one of these and then we will add it, right? So all the important formula will get again revised here of conductance. AgNO3 is getting added to AgBr. AgBr will solubilize as Ag plus Br minus. Solubility is S, and from AgNO3 the amount coming is 1 into 10 raised to the power minus 5. So I can directly write it as 10 raised to the power minus 5. So the concentration of Br minus is nothing but KSP upon Ag plus concentration, right? And this is equals to how much? KSP they have given 4.9 into 10 raised to the power minus 13 upon 10 raised to the power minus 5. So it's 4.9 into 10 raised to the power minus 8. This is the concentration of Br minus in the solution of AgBr and AgNO3. Now, Ag plus already we know, Ag plus concentration is how much? 10 raised to the power 10 raised to the power minus 5. NO3 minus concentration, do we know? Yes, it's 10 raised to the power minus 5 because AgNO3 is a stronger electrolyte. Now, the concentration of each of the following ions we know. Now, I need to calculate the specific conductance of each of these ions. specific conductance. The specific conductance lambda naught, or let's use this relation of Ag plus. Can I say it will be a specific conductance of Ag plus into 1000 divided by, since I am using at zero concentration, means I am using solubility, so I will write solubility of Ag plus, solubility of Ag plus, all the data is known to us. Lambda of molar conductance at infinite dilution they have given 6 into 10 raised to the power minus 3, 6 into 10 raised to the power minus 3 equals to some k into 1000 divided by 10 raised to the power minus 5. So from here I can calculate specific conductance of Ag plus. 6 into 10 raised to the power minus 3 into 10 raised to the power minus 5 upon 1000. Similarly, in the same way, we can calculate K of Br minus, K of NO3 minus, and K total equals to K of Ag plus K of Br minus plus K of NO minus. Right? Individual will calculate, because we know the concentration of each of the ions. We can calculate the specific conductance of each of these ions, and then finally we can calculate the specific conductance. Clear? So shall we move ahead? Let's move ahead. Next question, again it's application of Kohlrausch law itself. The question says the conductivity of weak acid H of concentration is, they have given the conductivity of a weak acid HA. They have also given the molar conductance of this particular weak acid at infinite dilution or zero concentration. What they are asking the ionization constant of this acid. Perfect. So they have given the value of K, and this K is 0. K of this weak acid, that's 2 into 10 raised to the power minus 5. They have given the concentration molarity, that is 0.001 molar. Now what we can do? We can calculate molar conductance lambda m, and this lambda m is K into 1000 divided by molarity. So this is nothing but K is how much? 2 into 10 raised to the power minus 5 into 1000 divided by molarity, and molarity is 0.001. Right? So it's 20. Simon, centimeter square. So molar conductance at a given concentration we have calculated. Now they have also given us the molar conductance at infinite dilution. We have studied Kohlrausch law, and this say one term degree of ionization is molar conductance at a given concentration upon molar conductance at infinite dilution or zero concentration, and this is 20 upon 190 upon 19. Alpha we know. Now this HA will dissociate as H plus plus A minus C1 minus alpha C alpha C alpha Ka equals to square alpha square upon C1 minus alpha. It's C alpha square upon 1 minus alpha. Alpha value we know. C value is how much concentration they have given? They have given 0.001. So alpha is 2 by 19. C value is 0.001. From here we can calculate the degree of, or dissociation constant of this particular acid or ionization constant of this weak acid Ha. Clear? Let's move ahead. Moving to the next question. Consider the following reaction. The quantity of electricity required in Faraday to reduce 5 moles of MnO4 minus H. Okay. A very one-liner question, I think. Perfect. I need to reduce 5 moles of MnO4 minus 1 mole of MnO4. 1 mole of MnO4 minus is requiring 5 moles of electron. Right? So 5 moles will require how much? Will require 25 moles of electrons. Do I need to calculate charge? In Faraday, I need to calculate 1 mole of electron is having a charge of 1 Faraday. So 25 moles of electron will have a charge of 25 Faraday. Right? Now, once again, a question related to conductance, specific conductance, and conductivity, right? So, important one. Can you solve this one? PCl solution is there whose conductivity they have given. What is conductivity? We have studied this formula. Conductivity equals to some conductance into cell constant, right? And what is this G? G is inverse of resistance. Now, a cell is there, a KCl solution of conductivity shows a resistance of this one in a conductivity cell. If the same cell is used, what's the purpose of using the same cell? Same cell means cell constant will be same, right? Now, is filled with an HCl solution, the resistance drops to 1.03 ohm. The conductivity of this HCl solution will be, okay. So initial conductivity is K. Let's assume it as G1. So it is same, right? So I can say for second one it will be K2, and K2 will be equals to Z2 into L by A. Perfect. Let's divide it. K1 by K2 is nothing but G1 by G2, and G1 by G2, G1 is nothing but 1 upon R1. So G1 is 1 by R1 and G2 is 1 by R2. So G2, it will go up R2 by R1. So we know K1, we know R2, we know R1, right? We can calculate K2. K2 is nothing but K1 into R1 upon R2, right? Simple. So shall we move ahead? Now, I hope it is the last question of electrochemistry. And again, this particular question is taken from Kohlrusk's law. They have given the molar conductivities at infinite dilution of few salts like, let me write itself, lambda naught of BaCl2 they have given. And this is how much? 280. Similarly, lambda naught of H2SO4 they have given, and this is how much? 860. Lambda naught of HCl they have given, and this is how much? 426. Now, using these three salts, I need to calculate lambda naught of BaSO4. Can I say it will be nothing but lambda naught of Ba2 plus lambda naught of SO42 minus. Now this BaSO4 is coming from BaCl2 and H2SO4. But now here this Cl is additional species and here H is an additional species. If I add these two and if I remove this HCl, 2Cl, 2H plus, so I multiplied by 2 and if I subtract it, I will get this. So can I write lambda naught of BaSO4 will be equals to lambda of BaCl2 plus lambda naught of H2SO4 minus twice lambda naught of HCl. Everything they have given, put the value and get the answer. Clear, everyone? Shall we move ahead? So yes, now we are done with electrochemistry also. In the electrochemistry part, what we have done galvanic cell, spontaneity, then we have done some Nernst equation of, even we have done the Nernst expression for this metal insoluble salt electrode, the pH and everything we have included, whatever is important. Then one equation was related to entropy, concept of entropy, S NF d upon dt at a constant pressure P. Then we moved to electrolytic cell where we calculated the mass of zinc produced, right? And then we moved to conductance where we did questions related to Coleridge's law, ionization constant of acids, this addition, subtraction, all these things, right? So again, all the important questions of electrochemistry I have covered in this particular lecture. Now it's time move to the next topic of physical chemistry, and that's chemical kinetics. Very important, very easy. Even this particular question is asked not only asked in JEE mains but in boards also. Such types of questions may be asked, right? And alternatively, every year they used to ask such questions in JEE mains also. A very easy one. I can say the most easy questions. So if we look at the question say our reaction is there, which is 2A plus B is giving C plus D, and they have given the results, the concentration versus the rate of formation. And what they are asking us to calculate the order of reaction. Sometimes what we see, we directly see stoichiometric coefficient is 2, stoichiometric coefficient is 1, and that's 2 plus 1, 3. But that's therefore elementary reaction. We are not so sure whether this reaction is elementary or complex. What I will write a general rate law expression, R equals to some K A raised to the power X into B raised to the power Y. Now I will have simple expressions. Once I can correlate these two, 1 and 4, and once I can correlate 10.2, yes, these two. We'll form two equations and two unknowns, and we'll solve the value of X and Y. Can we try it orally? 6, 2.4. So it's 4 times. 4 times rate of reaction is increasing. When the concentration is changed, B is kept constant, A is increased 4 times, right? So R is basically the ratio. If I'll say it's 4 equals to 4 raised to the power X, and this one will get cancelled, so the value of X comes out as 1. Now this one is remaining constant. 2 times, 4 times. So 2 raised to the power Y is nothing but 4. Y equals to 2. X plus Y is the overall order of reaction, and that's 3. Done? Am I clear, everyone? Shall we move ahead? The rate of formation of B is said to be 0. Actually, we should write, this would have written the change in accumulation or change in concentration of B is said to be 0. Then the concentration of B at any time is given by, we write dB by dt for this. First, let's write formation rate. This B is getting formed at a rate of K1A and it is getting decomposed at a rate K2B, right? This is overall the appearance of B in terms of A and B, right? It's getting formed at a rate of K1 times A and getting decomposed at a rate K2 times B. Now this dV by dt is 0 according to question. So that's K1A minus K2B equals to 0. The concentration of B at any time t will be K1A upon K2. Done? Everyone? Let's move to the next question. Now, if I have a look at this particular question, questions related to first order kinetics related with pressure. So like once again, a very typical and a very important questions. You must focus on this particular question also. Rather, will suggest please solve this question on your own. Can you solve it? Or shall I solve it? Okay, we'll solve it. Let us assume I'm having a gas A. This gas A is getting decomposed to B gas and C gas. Let us assume the initial pressure they have given. At T equals to 0, the initial pressure is Pi 0, 0. At any time T will have pressure Pi minus X and it will be X and this one will also be X. So what will be the total pressure? Total pressure Pt will be equals to Pi minus X plus X plus X. So this is Pi plus X, right? What's the value of X? X I can write it as Pt minus Pi. Now, first order kinetics, concentration of A at any time at beginning upon concentration of A at any time t, and then we can simply use this. Let me write it. Yeah. So if I use the first order kinetics, Kt will be equals to 2.303. You have, I hope you remember this, log of A naught upon AT. Since I am using pressure, so I will use P naught upon pressure at any time t. It's not total pressure, it's pressure at any time t. Let me write it here itself. So it's 2.303 log of Pi upon Pi minus X, because this is the pressure of A. This is the pressure of A at any time t, right? The pressure of A at any time t is Pi minus X. I have calculated the value of X. I will substitute it. Kt equals to 2.303 log of Pi upon Pi minus Pi minus X. Sorry, Pt minus Pi. X is Pt minus Pi. This Pi will go the side, so Kt expression becomes equals to 2.303 log of Pi upon 2Pi minus Pt. Done? Everyone? I hope you are crystal clear with this particular concept also. Whenever such question is asked, first calculate the total pressure, right? Then calculate the value of alpha, that is total pressure minus all these things. And then simply use first order kinetics A naught upon AT, concentration of A at any time t, or pressure of A at any time t, that is Pi minus X or A naught minus X. Put substitute the value of X. Simple questions related to this. Overall order of this reaction. This is 1, this is asymptotic in nature, okay, so we cannot even comment. And this is constant, it's not changing at all. Overall order of this reaction in region 1 and 3, the reaction is of first and 0 order respectively. The rate of formation of product is constant, AT. AT equals to A naught minus KT. Shall we write it? Let me write. Here it is ranging from, in region 2 the reaction is of first order. Yes. Overall order of this reaction is 1. Rate of formation of product. Perfect. A is getting converted to B, and dB upon dt is following y equals to mx. So kt, k to t, kt. Right? dt is simply following kt, so yes, here it's 0 order, and in these two, right? There is some ambiguity related to this question. Moving to the next question, and the next question which is there on the screen is, the reaction 2NO plus Br2 gives twice of NOBr. Takes place through the mechanism given below. NO plus Br2 gives NOBr2. It's a fast one, and the second one is a slow one, right? And whenever we write the rate law expression, we write rate law expression for the slowest step whenever any complex reaction is there. For any complex reaction, we write rate law expression for the slowest step. So what I will do, I will write R equals to K into NOBr2 into NO, right? But we'll have a look whether this NOBr2 is appearing in the final reaction or not. No, it's not appearing. So this NOBr2 is an intermediate, and in my rate law expression, the intermediate should not be there. We need to eliminate it. So what I am going to do is, I am going to use the law of equilibrium constant for this. K equilibrium equals to concentration of NOBr2 upon concentration of NO into concentration of Br2. So this NOBr2 will be equals to K equilibrium into concentration of NO into concentration of Br2, right? Now NOBr2 I can substitute here. R equals to K into K equilibrium into concentration of NO into concentration of Br2 into concentration of NO. So it is second order with respect to NO and first order with respect to Br2. Overall order is 3. A easy question, but a typical one. Have been asked several times. Right? Shall we move ahead? Okay. Can you do this particular question? Let me write the it will be one only, but you can do it. Easy one. Again, if we look at this particular expression, change in concentration of PtCl4 at any time T is given some constant into this one. is formation minus dissociation, Kf minus Kb. So Kf value they have given 4.8 into 10 raised to the power minus 5. Kb value they have given 2.4 into 10 raised to the power minus 3. K equilibrium is nothing but Kf upon Kb. Right? You will get the answer. Again, a typical one. XA is giving YB. Let's write the rate law expression for this one. Right? Can I write it like this? The rate of reaction for this one will be equals to 1 by Y dy dB upon dt. Right? So minus dou of A upon dt equals to x by y d of B upon dt. Everyone. Now, can I take log on both the sides? Yes. So, log of minus d of A upon dt equals to log, and log of this will go as log of x upon y plus log of d of B upon dt. So from here I can compare it. Log of minus log of x upon y, and this is log of dB upon dt. So what's the value of log of x upon y? Log of x upon y is nothing but 0.3, which is nothing but log of 2. So x by y is 2. X is twice of y. 2 of A is giving me B, where it is visible. 2 of C2H4 will give me C4H8. Right? Shall we move ahead? Now, once again, typical questions. Concentration versus time graph they have given. The first statement says the rate for the reaction is Ka square B. When the concentration of A and B both are doubled, so it's 4 and 2, 8. So rate of reaction becomes X times, and this X is 8. I hope it is clear. 2A, 2 square into 2B, and Rf upon Ri, so it's 8, right? And if we look at this particular A0 minus AT graph they are following, so it's a 0 order. So this y0, 8 plus 0, it's 8. Simple question, you can solve it. Now, this is a typical one. For a reaction taking place in 3 steps at same temperature, the overall rate constant is given. They have given the rate constant K as K1 into K2 upon K3. This particular reaction is occurring in 3 different steps and at the same temperature. If EA1, EA2 and EA3 are the activation energy value they have given, they are asking us to calculate overall activation energy. Oh, very good. Let's solve it. K, it's nothing but A into e raised to the power minus EA by RT. This is my overall activation energy. This is nothing but overall activation energy. Now I am going to write K1 expression. K1 is A1 into e raised to the power minus EA by EA1 upon RT. K2 will be equals to A2 into e raised to the power minus EA up 2 upon RT. Similarly, K3 will be equals to A3 into e raised to the power minus EA3 upon RT. If I multiply this K1 into K2 upon K3, what I'm going to get? I'm going to get A1 multiplied by A2 upon A3 to e raised to the power RT minus A1 plus EA2 minus of EA3. So if we compare it, overall expression will come out as EA overall will be EA1 plus EA2 minus EA3. Overall, it will be like this. EA1, EA2, EA3, all the magnitudes they have given 40 plus 50 minus 60. 40 plus 50 minus 60, that's 30 kilojoule per mole. Next question again related to rate constants, temperature, that's Arrhenius equation, correlating that particular equation. Easy one you can do. Let me give you the hint. Slope they have given, and slope is nothing but EA by R. So minus EA by R is how much? Minus 10,000. Now I need to calculate log of K2 by K1 equals to 2 1 upon EA upon 2.303 R 1 by T1 minus 1 by T2. K1, K2 value they have given, and I hope one temperature also they have given. The other temperature you have to calculate. Simple. So students, at this juncture, we are going to stop this class. Organic will do some other time. So thank you all for watching this lecture.